Okay, so how is everybody? Hopefully everybody is in good health. Yeah. And then last week we haven't started our fasting the fasting month yet, right? Or during our last session on Monday. I'm not mistaken. So a little bit late. This is the 7th day of Ramadan. Like to wish all the Muslims lah, especially happy fasting. Happy? Hopefully you're happy lah. This is a good month. Yeah, this is a good month. A month of barakah, called month of barakah, where there's a lot of reward. Promise to those that are doing good deeds and extra apa sunnah, yeah, during this month, extra reward. Okay, so I would like to continue from where we left off last week. Okay, for transformer. So I think I've already shared, right? I've already shared the lab manual, the lab manuals for lab 3, right? So in there you can actually see there are multiple experiments inside, where the first one is experiment 3.1, measurement of a resistance of the windings. Okay, and then experiments continued to by experiments 3.2, no load test of a single transformer. I think we did not do this. Do we do this? No, right? Kita payah buat kan? Okay, and then followed by number 3, which is the kita panggil apa namanya? This is just the no load test. Okay, the experiment 3.3, which is the short circuit test. Okay, short circuit test of a single phase transformer. Okay, so the point of experiment 3.1 was to look at the value, the resistance, okay, on the windings. Okay, resistance of the winding given the different voltage going through them. And then for experiments 3.2 and experiments 3.3, which is no load test and short circuit, it's looking at the power, okay, power consumption, and then power delivery, okay, with the transformer still with no load. Yeah, for Icha, pakai nama Icha kan. So yeah, boleh manual attendance. So hopefully the session kita tak stuck macam itu kan sekali kan. I was stuck at some point and then I had to restart, to rejoin, and then the messages to hilang. Then just leave me your number for those who wants to do needs to do manual attendance. Okay, and then first of all, we would like to ask: has all of you installed MATLAB yet? Ready?
Yes, sir.
Yes.
Oh, ada install. Okay, so for Unimas version, okay, for the one that we have here in Unimas, you can either install it locally, okay, where you need to download the installer again for MathWorks, or you can also use it through your browser. Okay, use it through your browser, the online version. Okay, where you can just go to the punya MATLAB website kan. Okay, MathWorks tu kan pakai yang online version, that one. But that one is limited to cloud storage. Cloud storage means you use your account to save your project on the cloud. Okay, save your project on the cloud, and any project that you want to load must be saved on the cloud. Okay, cannot you cannot run projects that are saved locally. So you can use either options. Okay, you can use both of the options. Which one do you prefer? But as long as you have a MATLAB version running, which version, I'm not really much care about which version. As long as you can do the experiments, is good enough for me. So how many attendance at the moment dah ada berapa orang dah ada? Oh, 91 already. Okay, so rasa boleh ni kan, boleh stop with ni siapa ni, apa nama, Norarisha class attendance. Kita pergi sini, students, no, salah sini. Here dah ni. Okay, dah tahan. Okay. Lain? Tak ada. Okay, so any luck on the experiment so far? Your report, you need to submit your report by the end of this week. Hari Jumaat kan? So I've already uploaded the link for report submission on eLib. Please check it out on our eLib. And then yeah, the due date will be is set to be on Friday midnight lah. Okay, before Sabtu. Okay, there's a lot of time for you to do your report. So just for saya stop sharing this one for a while lah. Mana stop share for this one. Yeah.
Sir,
Yeah.
I have question. Jangan marah, sir. About the due date, can
What?
we ask about the due date for lab report? Boleh ke extend sikit?
Apa hal? Dah 2 minggu ni.
Someone asking me to ask you for extend.
Berapa buat? That is the what already the basic of all the basic punya experiments. So why the need to ask for extension? And it's not today, it's Friday. Not enough time for to do it all until Friday. You can have time until Friday. So yeah. As for now, I will stick to Friday first. I will stick to Friday. I think you can still submit, right? You can still submit after Friday kan, walaupun dia already dia punya submission link tu dia tak tutup kan, even though after Friday it just said that you are late submission, itu je kan?
Yes.
Yeah, so that is what I will do. I will stick with the initial date lah, Friday. Boleh ya?
Okay, sir.
Okay.
Okay, thank you.
Okay.
So
Apa dia?
Friday tu submit lab 3.1 dengan 3.2 ataupun satu je?
No need to follow 3.1 and 3.2 kan. Yang saya pesan hari tu je. Yang hari tu saya suruh buat apa tu? Yang tukar power tu kan. Tukar power and then check resistance kan. Winding resistance dengan yang tu. Dengan apa coil. Apa tu? N. Bilangan N tu kan.
Yang tu first experiment saya cakap. Lepas tu second experiment saya cakap tukar winding satu. Yang tu kan second experiment which is 3.2.
Jap. Experiment number 1 hari tu saya suruh check yang
Tukar nominal power.
Kan? The first one kan?
Yes.
Okay. Yeah, and then the second one was check the winding resistance kan?
Tukar winding satu.
Saya nak check winding resistance. So can I have one group? Any one group want to share? Want to show the apa nama? The circuit? Boleh saya tengok? Kan saya sebut nama aja randomly ni ataupun siapa nak volunteer before we proceed with the next one today? Ada tak?
So, sir, nak reconfirm, sir. Kiranya 2 eksperimennya dalam satu report jangan sir.
Yes. Last week will be one report. This week will be one report.
Okay, thank you, sir.
Tak payah banyak sangat report lah. Saya pun kurang rajin nak check banyak. It's not like I can give you grades this semester. You still need to come back to Unimas and then complete actual experiments. Next semester. And then I don't know if you have heard that today the chief minister has made an announcement that schools are closed starting tomorrow.
Saya dah kelas lah kata.
In the red zone. So yeah, I already brought my kids here today. I brought my kids here today. Hari ni lagi saya dah cutikan diorang dah. Because of the current situation in Sarawak. Then don't know lah.
Sekolah cuti esok, sir.
Ya, bukan kita tak panggil itu panggil cuti kah? Cuti ya? Maybe the kids call it cuti. We call it closure. Actually closure. Sekolah ditutup lah. For unfortunate reasons, sekolah ditutup, and because a lot of schools in Sarawak, schools in Kuching, in Sarawak, in general, sudah banyak yang student kena COVID, and then cikgu-cikgu pun kena COVID kan. And then I have one of my niece in Sibu, sekolah dia jadi kluster. Sekolah tadika jadi kluster. Tadika kan darjah 1 ada. Okay, my niece now dia darjah 1 this year. And then the sekolah jadi cluster because like 25 of the teachers already positive, and then and then dia pula the students are asked to do the swab test today. So sian dia. Kecil darjah 1 kan, so buat swab test kan. Anybody here in the class who has been asked to do swab test? Ada? Ada tak? So far? Ke tak ada?
Ada. Baru buat
Ada?
tadi.
You?
Ya,
Why?
tak tahu.
You close contact with whom? With the case here, there.
Tak, satu area perumahan kena suruh buat
Ah.
swab test.
Okay. PD apa nama tu? CMCO kah? Apa nama tu? Yang di MCO ada apa nama tu yang perintah PKPD diperketat kah apa? Macam tu?
Tak tahu.
Hopefully nothing nothing really it's nothing bad. Okay, hopefully nothing won't turn out positive. Yeah. All the best wishes from me especially. Okay, harap tak ada apa-apa. Okay, sihat sejahtera. Maybe hopefully we can come back here in Unimas later kan. Yeah, especially it's so grim right now, the situation. Okay, so I will stop sharing this one for now. Saya dah stop sharing pun kan? Okay, so let's look back at the experiments. Tak ada orang share pun. Ada group mana nak share ke saya kena panggil nama ni? Okay, so saya tengok dalam list of attendance lah. Tengok list of attendees. Banyak lah. Mana saya nak sebut nama sekali lah. Ada nama yang kenal ni. Rizwan. Are you there, Rizwan? Muhammad Rizwan. Jangan waktu ni pula tiba cakap, oh tak ada ni rasa. Tak ada apa. Tak ada mic lah apa kan. Okay, Rizwan and the group. Adakah? Anybody group with Rizwan?
Yes, sir.
Ada? Okay, so any progress on the previous experiment? Nak tengok boleh?
Boleh. Sekejap.
Boleh, okay. I think you can share. I think you can share, right? Boleh kan?
Boleh.
Jangan share MATLAB share screen. Ataupun kalau you pakai the online version, share your browser. Sebab kalau you share the MATLAB, then dia akan share the program tu, MATLAB tu, jadi quite heavy. So sometimes some of the functions can work. So share screen lah, share screen. You open your, okay.
Like this also.
Okay.
Okay.
Okay. So so any trouble making apa nama building the circuit? No kan? Tak ada kan?
As of now, tak ada lagi.
Senang kan buat ni. Okay. The apa nama objective, the purpose of the experiments, this exercise lah, actually to familiarize you guys with MATLAB lah, with Simulink and doing this. Okay, doing this kind of experiments through simulation like this. Then so in terms of dia punya try run lah. Run.
So is it
This
okay
one
kalau
is
saya letak stop time dia 0.1 je?
okay je, boleh 0.1, then make it shorter.
Okay, hold on. It's running.
Tapi nama yang saya panggil tadi Rizwan. Rizwan mana? Apa khabar Rizwan?
Tak tahu, sir.
Hai, sir.
Oi!
Saya rasa toilet tadi.
Yalah tu. Saja buat terkenal lah Rizwan.
Benar,
Buat terkenal lah.
Hujan kan mahal.
Yalah tu. Saja buat panggil drama terus buat terkenal.
Okay, jangan.
Okay, so Dara, so RMS, so dia punya.
Okay, yang ni.
Okay, so ya, lebih kurang kan?
Lebih kurang.
Lebih kurang
Tapi
tu.
kan sir,
Ya.
waktu saya run kan dia selalu kata ada warning.
Warning is okay. Warning is something that you need to be. It just wants to make you aware of there is some macam connection tak ada kah. That's it. Just warning. It will not interfere with anything you are doing. Okay, just want to let you know. That's it. Okay, the one that will interfere anything in your apa nama simulation is error. Okay, kalau error then dia warna merah, kalau warning tu warna kuning. Okay. So error tu if there's a warning, cuba tekan warning tu, pergi warning. Okay, go to warnings, you boleh tekan dekat yang atas tu. Dia punya you go there and then it will show you that which one has triggered the warning. That one here lah. Okay, the one up over here, and this one is dekat mana tu? This one dekat RMS kan?
Dekat RMS.
Okay, dekat RMS. Okay, this one is something that kita tak kacau, so biarlah. Okay, so don't need to be worried about it. Okay. Because I was made aware that in different versions of MATLAB, dia apa nama tahun-tahun tu kan, dia sometimes dia punya calculation for RMS tu jadi a bit different following so that's why sometimes your simulation, your model from a previous version cannot be carried over directly, directly to the new versions. Okay, I don't know why MATLAB is doing this, but there are subtle changes from year to year. Okay, every time they come up with a new version. Okay, so yeah. So the one that previously maybe tak ada problem, and then when you bring it over to a new version, then tiba ada warning lah apa kan. Okay, but nothing to worry about. So thank you. So go back to this one here. Okay, so right now the input voltage berapa letak sini?
Input voltage.
Yeah.
Input voltage 400.
Okay, 400, and then ada eksperimen tu kita tukar berapa? Tukar kan? So for winding.
Dekat sini.
Okay, sini ada kan. So winding two parameters dia punya R2 to okay, so resistance tu kan boleh tukar kan?
Resistance yang R1 yang ni rasa.
Yeah, R1 and R2. Those are apa nama windings resistance. That one. Okay, that one winding resistance tu. Okay, that day saya suruh tukar yang tu kan. Saya suruh tukar apa itu? Dia punya power kan. Yang atas tu kan, nominal power. Okay, because we are using this model, the one that is linear transformer, so the windings resistance is actually constant. Yeah, it's actually constant. But did you find a way on how to actually measure the winding resistance?
No, haven't yet.
Itu saya suruh cari itu kan? Ada kan?
Bukan yang tu kira je ke sir?
Nak kira je kah? Tak boleh nak kira because this is the experiments. It should be we need to do it through experiments, measurement. Okay, kalau kira baik tak payah buat lab, kita bagi buat kelas, bagi sekretari lah.
Okay.
Okay,
Sekejap,
saya pergi kita jemput Dr. Sophie lah di sini. Dr. Sophie apa nama? Puan Masniah kan? Dia orang ajar segi teori. Maybe I'll leave because I will tell them you like to calculate that much, so maybe let them take over.
Sorry, I
Okay,
didn't
so
know.
what if we change? Okay, so what if you change the winding resistance? Okay, cuba tukar some of it. Tukar value to a value that you like. Ya, kedekut ah.
Tak boleh kah? Kejap. Tak apa-apa lah sir. 0.1 kah? Both kan, sir?
0.02 bagi 0.04 mak ai kedekut gila. Okay, first of all tadi you need to record the output tadi sebenarnya. Okay, tahu tak macam mana record output? Hopefully everybody is also paying attention. Macam mana kamu buat output tu, kamu nak letak dalam report?
Kat scope je kah?
Bukan scope tu. How?
You just input dekat sini.
Yeah. So how do you save that input? Save that display scope.
Oh, save the scope.
Ah.
Oh, you mean macam screenshot yang ni kah sir?
Itu saya tahu kamu buat screenshot kah?
Tak, copy to clipboard je. This one and yang print.
Okay, so kita letak print to figure bagus Kalau if you do print to figure, okay, kalau you letak print to figure dekat atas tu, it will do everything. Dia buat semua scope sekali. But you can actually do individual scope by right click on the scope that you want. Which one? Out of these four, click one. Right click one. This one is already figure. Tutup figure. This one is already figure.
Oh, this one.
Okay, yeah. Right click here. Oh, you pakai Mac kan? Okay, so kita Windows pakai click to figure, right click kan. Mac pakai apa? Long click.
I don't know.
Okay, tu print to figure tu.
Print display to the print.
Yeah.
Okay.
So you can get one.
Oh.
So this is how you do, and then this figure is actually still modifiable You can change the value tu, dia punya access tu semua. Okay, to better suit your what you need to look for. Okay, macam yang x-axis, y-axis kan. Okay, you can still modify. So that is how you save lah. Before you do measurement, before you change the value tadi dalam resistance kah, tukar voltage kah dalam experiments tadi kan, dalam you punya model, you save the one previously. Okay, you save the one that you have done previously, and then you do comparison.
Okay.
So right now, but in order to do comparison, you need to have the same setting lah. Dia punya apa nama? Ni kan. Okay, so thank you. Ni boleh stop lah. Stop sharing. Thank you.
Okay.
Siapa ni? Aida.
Okay, thank you sir.
Okay. Yeah. So hopefully everybody is has at least also when apa nama up to that point semua dah ada kan sampai situ okay kan? Ada yang problem kah? Anybody with problem? Any problem with that? Ada? Tak ada? So, um, so ini tadi ya. So, last week I asked you to do to find the winding resistance, but actually the winding resistance is already here. Yeah, winding resistance already here. So no matter how you do, even if you are able to do the measurements, you will see that the value of the resistance are constant. Okay. So what you can do is here. Okay, you change the unit to SI. Change the unit to SI first, and then you change this one. As you can see, this one already changed. Tadi sini pakai PU kan? Sini. Okay. As you change it to SI, then it will change this one to ohm and Henry. Okay. So for windings number 1, okay, you can change this value. Okay, change this value of resistance. Okay, whether you see if you increase it and if you decrease it, how it affects the voltage and current that you get in the scope. Okay, so sepatutnya itu saya suruh buat tadi tu because saya tak perasan this one yang tengah-tengah ni. Even if you measure the windings, it will be the same. Okay, it will be it will be just the same. So for yang windings tadi, for yang winding apa nama winding resistance tu, you need to do what you need to do is change this one boleh tak? Okay, tukar instead of hari tu kita tukar dia punya power kan? Tukar dia punya power to measure any changes in the tu. So for the actual report kita tukarlah. Tukar kita sini kita letak berapa? 5,000, 10,000, 5,000 lah. Okay, 5,000. 5,000 and then for the windings ni kita tukar ke changes in windings number 1 and changes in windings number 2. Okay, so the changes is up to you. Okay, I will leave the changes to you whether you increase it or decrease it. Okay, increase and decrease the winding resistance here. Okay, to apa nama pergi berapa ohm lah selalu kita letak 100 ohm, 200 ohm, 300 ohm. Okay, this one also. Yeah, for winding resistance number 2, you can also change it and see how it affects. So contoh sini, okay, ini saya dah pakai load. Sekejap ah. Because I was testing the model just now. So sini kita, apa letak sini hari tu? Branch.
Sir, tok 3.2 kah?
Ya, yang 3.2 tu.
Oh, sorry ya. Saya cakap suruh tukar voltage nak?
Saya suruh tukar power hari tu kan?
Untuk second experiment saya cakap tukar bahagian voltage yang
Tukar voltage
je.
Okay, so tukar voltage. Itulah saya cakap. Because the purpose was to measure dia punya apa tu? Dia punya resistance kan, winding resistance.
Yes.
It's just that because this one kita pakai because there are a lot of transformers in Simulink. Okay, a lot of transformers model that we can use, but because we are using this one, the simple linear transformer tadi, okay, the windings resistance is given here. You can actually set the winding resistance yourself. So even if you change the value outside, the resistance will be the same. Will be constant because you already set the resistance here.
Oh, so it means jadilah tukar voltage.
Ya.
Voltage yang remain the same.
Dah dapat kira belum?
Ya.
Dah dapat kira belum?
Kira
Winding
apa?
resistance. Dah measure?
Belum. Siapa?
Nah kan. So before before you start to you start changing that one. So maybe I should change the content a bit. Okay, because the winding resistance is here when you change to SI, and then winding resistance here, and then sini tadi saya ada apa kita panggil apa nama branch RLC RCL kah RCL
LC.
RLC branch kan.
So it means jadi lo nak tukar voltage.
Saya rasa bagus tukar. Bagus tukar. Sebab
Tukar.
bukan yang voltage tu saya rasa okey, voltage tu kita tak kacau.
Maintain
It's
400
just
lah.
that apa nama ini 400 to 200 tadi. It's just that because ni tadi I want you to see the effect of this is default this is default winding resistance. As you can see, in order to reduce, okay, in order to minimize power losses in the transformer itself, because okay, we want to use transformer to step up and step down voltage, right? Okay, but we don't want it to consume any power. Okay, we want to minimize power losses, okay, through a transformer. But although ideally we want the losses to be zero, but in real life, as long as there are components added into the system, like in this case, because it's just not possible, like I said, it's just not possible to transfer the power directly from yang empangan, contoh dari bakun directly to your house. Okay, directly to your house in 240 volts. Now, hantar daripada bakun directly to your house. It's not possible. It's possible, but not practical. Okay, it's not practical due to losses involved and the distance lah. The losses due to the transmission distance. Okay, so transformers are added in. So as you should be aware by now, when you add a component, okay, every time you add a component inside, power consumption will be increased. Okay, power will only increase. The amount of power will only increase with an additional items, with additional component. Okay, walaupun kalau kita pakai series ke parallel connection or series connection, okay, it's power calculation is not like the calculation for resistance, not calculation for yang voltage kan. Kalau kalau kita pakai parallel, then V1 equal to V2 equal to V3 kan. Kalau series is V1 plus V2 plus V3 kan. But power doesn't matter if it's series or parallel, is power P1 plus P2 plus P3. Okay, so every time you add in a component, it will become additional power consumption. So here with the transformer, it is a necessity in transmission because we need it to step up and step down voltage to reduce losses. But we don't want loss. There are losses in the transformer itself. Okay, so for an ideal transformer, of course, this is nama ideal. Ideal transformer, there is no losses at all. Okay, there is no losses at all involved within the transformer. But but we look at reality, there will always be a little bit, just a little bit of losses due to the use of transformer. As you can see here, it puts the internal the resistance as 0.10667 here as default, and as you can see, this one is a very small value. Okay, it's a very small value of resistance, means the amount of power losses caused by this transformer is very little. Okay, very small. So what here what we can do is, this winding resistance, you can increase it, okay, increase it further in the form of 100 ohm, 200 ohms, 300 ohms, okay, ataupun you nak skip pergi 100, 300 sampai 1000 ohm kan, okay, 1 kilo ohm, and see how it affects the power delivery. the amount of current, and amount of voltage, okay, in the circuit. Okay, you can see that. Okay, the same with this one. Okay, you increase or increase lah, cuba increase this one and see how much it affects the power deliver the operation in terms of primary and secondary voltage lah. Boleh? Okay, so that will be the second one lah. So the increment is up to you. Okay, the increment is up to you as long as you can see the changes and effect of the internal the increase of internal resistance, so the winding resistance, sorry, then it should be fine. So here kita letak R saja kan hari itu kan, R, so kita letak 100 lah, lebih kurang kan, apply. Okay, so as of right now, ini pun saya tak 0.1. Okay, 0.1 dah. Saya kena stop dari tadi. I need to run it again. Sebab saya dah run tadi. That's the weakness of this one. Okay, so because I dah run tadi, then when I run it again, dia tak nak. I don't know why. Okay, so ini apa, load branch. Okay, so kita letak R. Is that applies here? Yeah, okay, 0.1. That's salah. 0.1, and then kita run. So we got a similar results like that day kan, sama kan lebih kurang. Okay, so just for the sake of it, kita let's save one lah. Let's save one in terms primary lah, primary current. Kita letak primary current. Okay, saya save satu ni. Okay, this one is tadi primary current primary current before we change. So what if kita tukar sini jadi primary windings of this one. Okay, kita tukar jadi 10 ohm. Contohlah. Okay. Kena tak? Primary, so primary current, itu jangan. So this one is a new one. So any changes to the value? As you can see, susah tengok. Yap. Ini sama kah? Sama size lah. Okay. Notice any difference?
Ada beza sikit. Ada beza
Kan?
sikit. Ada peaknya.
Okay, so as you can see, there is a difference in terms of dia punya amount of voltage tu, amount of current, sorry, amount of current tu berbeza. Although in terms of voltage, there is no difference. Okay, because the input voltage is still 400. Okay, but as you can see, current will change. Okay, due to the increase of winding resistance. Okay, so what you can do is, yeah, this is just an example where you increase it further and see, you boleh kira power tak? Okay, boleh kira power. Okay, you measure the power here, and the power in the secondary. Okay, tahu tak cara kira power? Okay, you need to insert a power meter. Okay, like here in this experiment, nampak tak? This is experiment 3. Ini experiment 3.1 3.2 I think. Okay, you can actually install a power. This one like I said here, cost. Ini apa simbol ni? Saya dah lupa bacaan dia. Fee. Apalah fee kan ni? Saya lupa simbol dia apa. It's a single phase electrodynamic power factor meter. Okay, means you can actually measure the power. Okay, you can actually measure the power. Okay, from in the windings. So what you need to do is, okay, by increasing the amount of voltage tadi, okay, measure the power here. Okay, yang power tu untuk the second experiment today boleh tak? Yang hari tu kita tukar ni saja, voltage and current saja. Beza. For 3.1 tadi, we stick with this one. Figure 1 and figure 2, this one. Boleh Okay, as you increase the... Tadi saya tak kira macam mana yang yang the first one tadi. I2 saya tak kira. Ada changes ke dengan I2 tadi? Ada orang perasan?
Macam saya dah ubah resistance-nya.
Ya. Saya tak perasan, saya tak tengok tadi current I2.
Cuba
Okay, I secondary.
100.
Around here, right? Tadi this one, secondary current, saya tak check. Okay, so so changes in the windings will impact the current lah, the current value. So it will also impact the power. Okay, impact the power means losses lah, means there is a losses. Okay, means there are losses inside of the transformer itself. So for experiment 3.1 tadi, yang the first apa saja jadi besar sangat ni. Okay, eksperimen yang tadi mula-mula tu, you tukar windings punya resistance. Okay, you tukar winding resistance, winding resistance, winding 1 and winding 2 tu, it's up to you. The increment tu, it's up to you, how much you want. So as long as you can show the difference, it's okay. And then for experiment that we are going to do today is actually on the load. Okay, on the load. Itu tadi masuk sekali lah, kira power sekali terus lah. Boleh tak kira power sekali? For experiment number 1 tadi. It's easier to show the difference in terms of power lah. How much power is lost due to the increment of the resistance. And then for the second experiment that we are going to do today, is actually, alamak saya salah tekan kah? Okay, so it's actually to change this into a branch. Kita nak tukar dia jadi load. Okay. Sorry, saya dah terbuka another instance of MATLAB. Satu je saya tekan tadi. So, sorry. So, experiment, yeah.
Yang eksperimen second pada report baru ke?
This one is for this week.
For
This week is, yeah, for yang tadi tu yang winding current tadi kita winding voltage tadi tukar. Winding resistance, sorry. That one is for last week.
Alright.
Okay, for last week. So for this week, I want you to replicate these experiments. This experiment shown in figure number 1 here in experiment 4, transformer load operation characteristics. This one, I will share this online. I will share this in our ELIP later. Replicate these experiments to see the apa nama? Ni, by changing the windings ni. Okay, changing the number of windings tu. Okay, like this one kan. Okay, the number of winding for this one, if you are using linear transformer, you cannot change the number of winding, but you can simulate that the changes of windings tu by tukar voltage ni kan. Betul tak? Okay, by changing the output. Okay, by changing the outputs, you are effectively actually changing the number of windings. Betul tak? Kata betul?
Betul.
Betul kan? Okay, so the one that I want you to replicate is this experiment here that we have in shown here in experiment 4. Okay, so you increase sikit lah, you increase the input to be more than 400, maksudnya dalam lebih besar lah, so that this one make it bigger, more than 400, maksudnya contoh dalam berapa? 1000 kah? Okay, 1000 boleh. Okay, 1000 boleh, so that you will have it easier here, means winding number 1 is 1000 kan, sini winding 1 the voltage is 1000 contohnya, 1000. Okay, so windings number 2, you boleh tukar number n dia pergi berapa? Jadi kalau 240 tadi dah lain nombor kan? Okay, that is 1 and 2. Okay, so kalau you tukar jadi 120 kan? 120, it's different N2 already kan? Windings number 2. Okay, and so on. So you change the number here. You change the number to macam contoh pergi 350 kah? Or 500. Okay, you apply, and then this is effectively meaning you are using a different number of windings in the second one. Okay, and then what the experiment is asking you to do for experiment number 4 is for you to measure power again. Okay, to measure the power in the secondary circuit here, in the secondary windings. Okay, power thereby using the RCL load. Okay, RCL load. So that's why here tadi saya ada letak ni kan yang tukar. This one. Okay, so that's why tadi saya ada buat yang load tu. RLC load. Okay. Here is where you experiments. Okay, either you want to use series load kah ataupun parallel load. Okay, here is where you experiments. But just don't forget to record lah which one lah. So like this one kan. Okay. You can change you can change here, but due to this one, because kita pakai using this one nominal voltage tadi kita bagi. Okay, so don't forget to, because this one is dia punya calculation is in RMS. RMS, the one that is supplied here is, kalau kita tukar this one, okay, this one tadi branch, but because this one, if we put one of this here, contoh this one lah, load here, okay, don't forget that this one dia kira RMS, okay, dia kira RMS. So calculation of RMS tadi sini dia pakai RMS, so berapa? Kita darabkah bahagi dengan square root 2? Darabkah bahagi? Ada orang nak bagi ni kah? Okay, because ini the one that we use for this connection is V peak, peak. Okay, but this one uses RMS. So please make sure that you put a proper voltage here. Like, okay, like right now, contohnya 500. So it should be apa dia? So right now should be berapa? 500 bagi ke tak?
Divide.
Bagi ke tak? RMS.
Bagi.
Bagi kan? Okay. Cara square root macam ni eh? Macam ni eh? Divide kan? Okay, I will leave this to you. Okay, square root 2. Kita kira RMS senang saja. Okay. Because this one is V peak. Just remember? Okay. So right now kita pakai 500 kan? Okay. So ini dia error lah sebab tak boleh pakai kan. So find a way to letak square root 2 tu. Okay. And then here is where you experiments on using any of this. Sebab dia nak tengok sini adalah the purpose of experiments is this okay. Dia nak tunjuk this one. Okay, so in figure 1, so dia kata the phase relation between the delivered current I2 and the voltage U2 across the second terminals of the transformer depends on the nature of the load impedance Z, which is the one that we are going to put here. Okay, this one or this one. Okay. And then looking at figure 1, okay, in figure 1, the impedance Z is inductive, means in figure 1 here, in this figure 1, the load here is inductive, means there is a resistance and then there is also an inductor. Okay, so you can change this into sini you letak sini kosong, dia akan tukar jadi macam ni. Okay, so that's how you make an inductive load. Okay, so dia kata tadi the inductive, therefore the current I2 is lagging of a certain angle. Ini phi kan, phi 2 with respect to the voltage U2. Okay, so the experiments is for you to show that this delay. Okay, how to set this load to have the current delayed, lagging, this lagging the voltage due to this inductive load. Okay, so the current I2 crossing the secondary winding provokes an ohmic voltage drop due to the resistor R2 here, and then an inductive drop due to the leakage reactance X2. Okay, consequently, the voltage U2 available across the secondary terminals of the transformer on load is different from the secondary electromotive force E2. This voltage is different than this voltage due to this load. Okay, because part of this EMF is used to win the two above-mentioned internal drops. This one and this one. This one and this one, sorry. So, the phase shift angle P2 between the voltage across the terminal V2 and the current I2 depends on the nature of the external circuit, which is this one. Okay, so I would like you to attempt this. Okay, I will not put set a due date for this yet. Okay, I want you to read this and try to replicate this using this circuit that you have built earlier. Boleh? Okay, try to replicate these experiments using the circuit that you have built earlier. Then you can use this this procedure as a guide. Okay, as a guide for you to do it. Boleh? Because the nature of this one, these experiments, kalau asal-asalnya adalah it is partially open-ended. Okay, it is partially open-ended. The due to their nature, as you can see, the procedure is not provided by default. Okay, you need to look at the experiment setup, okay, and come up with the suitable procedures for the experiment. Okay, so that will be experiments number 2, but okay, I will not put a deadline on it just yet. Okay, so for next week, I want to see all groups, okay, present this one in the circuit, okay, their circuit showing yang ni tadi, right? As of right now, as you can see, there is no lag. Okay, there is no lag in the circuit that we are using currently. There is no lag because kita tak pakai load yang apa inductive or capacitive load kita pakai. We are just using the branch tadi pun kita letak branch yang ni saja kan. Okay, resistive saja. Resistive branch means there is no lagging. Okay, the impedance is in ohm saja. Dia tak ada apa nama yang apa nama tu yang complex part. Okay, ohm dia punya impedance is dia punya resistance. Okay, but try to use this series or parallel RLC load ni using your knowledge in circuit theory lah to show the current lagging or leading the voltage. Okay, boleh tak? Boleh tak? Kita boleh?
Boleh, sir.
Boleh kan? Okay, there will be no report yet for this one. Okay, I just want you to replicate these experiments using the circuit that you have built previously. Okay, so yang eksperimen, so kalau kamu sayang yang asal-asal tu yang kamu buat, so just do a copy lah, do a copy of the file so that you don't have to kacau yang the experiments before. Okay, and then for the second experiment tu, try to replicate this by okay, by apa nama? Ni tadi lah, by using this or this. Okay, to show there is a delay here. Berapa delay tu tak kisah dulu. Saya nak tengok ada delay dulu. Boleh eh? For the second experiment, we will use the default value. Bukan yang value yang you dah tukar for the winding resistance. Okay, winding resistance, we will use the default one so that there will be minimum power losses here lah in the transformer itself. Okay, I want you to use this platform, okay, to show what this experiment means here. Okay, so untuk minggu depan saya nak tengok itu saja. Tengok circuit saja. All groups must present, must show their circuit saja next week. Understood? Boleh? Boleh?
Okay, sir.
Boleh eh? Okay, ada seorang yang jawab. Saya kira wakil lah. Okay, anggap wakil sebagai semua lah. Boleh kan? So, work with your group member. Okay, group members. Okay, to build the circuit and find a way to replicate this. Okay, and then at the same time, completing the experiments in the experiment 1 tadi lah. Okay, the first experiment, the one previously, tadi kira sini, kalau power tadi, you kira power sini saja, power, okay, sini kira power sahaja tadi, berapa? Kalau yang ada, yang tukar winding resistance tadi, you can show the difference tadi in terms of the current tadi kan? In terms of the current, you can also do the calculation in terms of power. Okay, berapa the new power, how much the power value has been affected. Okay, has been affected by the changes in the winding resistance. Okay, But that one is for the first one, and the first one, you kira power. And then the second one tadi, just for now, I want you to replicate the experiments in experiment 4. Here. Okay. So I will share this on ELIP 2 after this. Okay. So you can start working after this.
Hi,
Yeah.
it's me again.
Yeah.
Yang eksperimen awal tadi apa nama lab ya? Lab 3 kah ataupun lab 3.1 kah or lab 3.1?
Bagi lab 3 saja.
Lab 3 je namanya.
Lab 3. Tapi sebab ada 2 task kan dalam tu kan?
Yes, yes.
Nah, so letaklah 3.1 and 3.2.
Okay, so yang
Okay.
replicated yang coming
This
soon
will
tu
be your
will be
experiment 4. Experiment 4.
alright, clear.
Okay. This will be experiment number 4. But saya nak tengok dulu that lagging and apa nama tu lagi satu tu leading lagging and leading kan. Okay. Cases. Okay, you can find the solution mana-mana dekat internet kah mana-mana kah, up to you. I just want to have a look at the circuit for next week. Okay?
Hello sir.
Yeah, any more question? Yeah.
Sorry nak tanya. Untuk 3.1 this one just nak reconfirm. Untuk for 3.1 kami tukar power,
Yeah.
nominal power untuk cari winding resistance, correct?
Sekejap, bukan. Itu dah tukar. Kita tukar. Tadi tukar. Yang that one no more. Because that one. Okay. So, I'll say this again lah. Okay. In this simulating MATLAB. Okay. Apa saya cari MATLAB kat sini. Kita cari transformer. Okay. Kita cari. There are a lot of transformer in here. Okay. In simulating that you can use. Okay, so that experiment tadi, kalau kita tukar power apa semua, nak cari windings tu kan, can be done, but if we are using this. Okay, this one. Okay, tengok ni sekejap. Oh, jauh, lama je dia tarik Mana winding tu hilang? This one. Okay, where we build our own transformer here. Pun tengok sini pun winding dia kita tetapkan sendiri. Okay. Okay, number of windings pun kita buat sendiri semua kan. Okay, but I don't want you to use this. Okay, I want you to use this transformer. But due to us using this transformer, the winding resistance is already given. So no matter how much you change the power, the resistance won't change. Will not change because it's already set in the model. Winding ni resistance dia banyak ni saja. Tak akan tukar. Okay. So what you should do is now we change that task to you yourself change the winding resistance. Okay. And as I shown just now, there are changes in the current value kan. Okay. When you increase the winding resistance, the current value become lower. Betul? Okay. It becomes lower due to the increased resistance in the windings. So use the yang value tadi to show how the increase of windings to makes the value of current smaller, and then you can prove it by doing the power calculation lah. You can either put a power meter somewhere here or just kira P equal to IV lah. At windings 1 resistance 10, macam like this one I put at 10 ohm saja. Winding 1 resistance at 10 ohm, the power value becomes berapa? I darab V. Okay, I darab V. Kita ambil RMS lah kan, RMS of this and RMS of voltage and RMS of current darab. Okay, darab dapat berapa? Okay, compared to the one here yang sepatutnya voltage ini tadi, okay, so tapi kita tengok sini bolehlah, okay, power dia tadi, power sini berapa, and then power dekat sini berapa. Okay, when you change the windings lagi, change pergi, contohnya pergi 100, okay, 100 ohm now for the first windings. Okay, for the first winding, you change to from 10 ohm pergi 100 ohm pula. So how much it affect the current, and then now berapa power dia? Okay, the new power due to the increase in windings. Okay, as long as you can show that one, it's okay to me. So that's why I will leave the increment to you. Okay, how much you want to increase sampai berapa, it's up to you. Okay, that will be the task yang number 1 tadi lah. Okay, task yang second one kan, 3.2. Okay, 3.1 is apa itu kita increase berapa? Increasekan voltage sini kan?
3.1 increase power, sir.
No.
3.2 winding.
3.1 kita increase power, kita increase voltage sini kan?
Yang
Increase
tu
voltage.
3.2.
Kita pergi, oh itu 3.2. Suka hati lah kamu nak letak 3.1 kan 3.2. Okay, either one lah. Yang satu tu kita nak kira number of windings kan? Okay. The other task is to calculate the number of windings. Kita start tadi input dia daripada berapa? 100, 200, 300, 400 sampai berapa kan? Kita increase here kan? Sini for the second winding kita nak 240 saja kan? 240 because we want to use that value here. And then here is 100, 200, 300, 400 kan?
Yes.
That one is task, the other task. So itu up to you lah. You nak letak itu 3.1 ke itu 3.2. But those are the two tasks I remembered I gave you last week.
So it mean for lab yang awal tu, lab report, we have like two
Yes,
things.
two experiments.
First yang cari power, yang saya
Yeah.
mau and then second saya mau cari how many windings.
Yes. Because here using this transformer kita tak ada number of windings. Ya betul kan? Tak ada number of windings kan sini.
Kita dah.
Okay, so number of so yang for number of windings tadi, remember to use this one PU pakai PU. Okay, it's easier. Okay, just tadi yang when you want to change the windings resistance tadi pakai SI. Okay, those are two tasks for experiment number 1 that you need to submit by Friday lah. Okay, by Friday. Clear or not? Clear kan? Boleh kan? Tak ada jawapan kira apa kita apa orang dulu cakap apa? Tak ada diam tu tanda setuju lah. Ya.
Untuk lab ni kan sir, yang lab 3 ni kita cari apa sir? Yang 3.1 and 3.2 ke?
Ya, yang saya share minggu lepas tu yang apa nama? Yang ini saya share minggu lepas kan, this one. Ini saya share saja, but there is no need for you to follow this exactly the experiment. Ini just I want you to look at the yang formula ni. Okay, dengan dia punya teori. Okay, what you need to do was what I explained to you just now. Okay, you kira the ratio of windings tu, because tadi kita pun tak tahu windings ni berapa. Kan, the first winding berapa, second winding berapa kan. But you can use N1 and N2 here. Okay, use the formula to calculate kalau kita 100 sini 200 sini with the power tadi 100 volt, sini 200 volt. Okay, berapa ratio of N1 and N2 tu? Boleh tak?
Boleh.
Ratio of N1 and N2.
So tengok ratio lah.
Ratio, tapi itulah kalau kita kira macam tu, then kita dapat ratio sahaja kan?
Yes.
Ya,
boleh
kita dapat ratio sahaja. So, bukan boleh dapat tak? Kalau ikut formula?
Saya tahu malah.
Boleh dapat kan kalau ikut formula?
Saya tahu lah. Complicated lah sir. Dah lah banyak report tak mahu perlu submit this week.
Ya.
Ya, banyak.
Ya, macam mana nak buat? Kita dah jadi macam ni kan? So, ya, kita as of right now kita buat ratio saja. N1, N2.
Okay, nice.
Okay? So that is the first task. Second task tadi adalah you increase the winding resistance.
Alright. So apa yang
Okay.
pakai SI tag sir?
Itulah SI for the second experiment, PU for the first experiment.
Okay.
Okay? Okay,
Alright.
PU untuk ni eksperimen second for the yang lagi satu yang kira apa nama tadi? Ini kita kira winding kan? Ini kira
Yes.
number of winding, and then ini nak kira power. Okay, when you increase the this one, dia punya winding resistance. Okay, those are the two tasks for experiment 3. Okay, tak apalah, saya akan simplify after this. Saya letak dalam Word arahan dia, and then saya share dekat ni lah. Okay, saya share dekat Elip lah after this. Okay, so no more confusions. Okay, for experiment number 4.
Sir,
Yeah,
the video can you upload today?
mana? This video? You mean this video? Oh, okay, saya tengoklah. Saya cubalah. Okay, saya cubalah. Okay, so for experiment number 4, okay, I will also share this online today. You just need to replicate this in Simulink. Okay, try to replicate this and show yang lagging tu.
For the report, kena include calculation dalam report ke?
Kena lah. Kalau tak calculate, lepas tu kamu nak letak mana? If you don't put in the report, where do you put it? Macam mana saya tengok kamu kira?
Oh, okay, sir. Thank you, sir.
Okay? So I think it should be in the report lah. Okay? So I will update the instruction for experiment 3 and experiment 4 after this on Elip. So for experiment number 4, you just attempt to replicate this experiment 4. This is the first one. Okay, the first one here. Following this experiment, this one here. Okay, to replicate this one, the lagging tadi, the effect of the using. Sini dia pakai apa ni? Induktif saja ke dua-dua? Induktif dengan kapasitif. Tak ada kan? Dia pakai induktif saja kalau tak silap saya. This one. Okay, I think this one it sticks with inductive load saja. Okay, but you are free to try. Okay, you are free to try. Okay, to do experiments on your own. Letak RCL sekaligus pun tak ada masalah. Okay, that's the point of experiments. Lagipun ini tak ada equipment rosaknya. Okay, kalau dalam lab takut sikit saya nak bagi kamu try ni kan. Buat itu takut equipment rosak dan orang lain tak boleh pakai dah. But this one is Simulink. Okay, you can try to your heart content. Okay. So that's it. That will be it for today. Okay, so those are the two experiments, 3 tasks kan. 2 experiments, 3 tasks. Betul lah. 2 tasks for experiment yang 3 tadi, and this 1 task for experiment 4. So as for right now, I will stick with the due date tadi hari Jumaat. So as I see fit, if I see that no, I will stick to that date lah. Okay, kalau boleh, I will stick to that date for now. So there will be no class tomorrow. We'll see again on Monday. All groups must show their results, their circuit next week. Okay, for experiments number 4. Okay? Yeah.
Sir,
Yeah.
yang untuk lab 3.1 dengan 3.2, nominal power dia fix ke sir?
Yes.
Alright sir.
We just fix it lah. Because hari itu saya suruh tukar. Nak suruh tukar, ingatkan boleh ni, saya tak perasan yang sini. Dia punya apa nama? Winding resistance tu dah fix. So even if you change the power here, there will be no change because resistance ni yang menetap apa nama? Will determine the power output of the transformer. So yeah, even if we change this and we don't change the value here, there will be no change. The resistance will remain the same. So that's why instead of changing the power here, ini letaklah power decide one 5,000 ke 6,000 up to you. Okay, up to you. That's why you need to keep the setting. Okay, setting ni kena bagi tahu when you do your reports. Okay, setting dia ni kena at least buat screenshot kah for this one, because ini tak ada letak dalam figure for this one. So save this one, screenshot this one, this setting, so that kita tahu apa yang bertukar, apa yang tak tukar. Okay?
Okay.
Yeah, so this one letak 5,000 pun okay. But change this one lah. So kalau pergi jadi berapa? 2,000. Yeah.
Yang screenshot ni masuk dalam metodologi lah kan sir? Kita change dia satu-satu tu. So letak gambar description tu ke dalam result?
Ya. Kalau yang tadi pun, kalau yang change pun, ini tak payah lah. Ni buat screenshot sekali je. Yang ni kan. Screenshot sekali je. This one you put in the table kan. Nanti you letak berapa? 10, 20, 30 kan.
Tapi saya kata semua tengok screenshot je.
Tak payahlah semua screenshot. Because nanti nak letak apa? Because you need to do it. You need to do a table, right? Okay.
So that's mean kita orang belajar screenshot satu, tapi buat table untuk perubahan setiap apa yang diubah.
Yalah, because ini winding one kan, and then sini winding two. Okay, and then of course you need here is power lah kan, P.
Power.
Okay. P sini P1 dengan P2 kan.
Okay, yes sir.
Okay, sini P1 and P2. And then sini adalah VRMS tadi, V1. V1 dengan I1 lah. Kan? Macam mana saya letak tu? V1, I1. 1. Tak dapat sangat. Okay, the same with this one lah. So, macam ni lah lebih kurang. Ni kan berapa kan? Okay, winding 1 berapa dia punya resistance tu? Sini in ohm. Ohm berapa kan? Okay, berapa kamu tukar? Sini. And then winding 2, whether you change or not, it up, okay, depending. Kalau kamu nak buat 2 table pun boleh.
So in result answer untuk tengok dia punya perubahan dia tu.
Yeah. Whether, okay, you can do 2 table pun boleh. Means this one constant. Okay, this one constant. Salah. Macam mana? Constant.
So no need to put the screenshot dalam kita punya report lah saya. Confirmation lah.
Yeah, up to you. Tapi
you say you want to see the screenshot right now.
No, I want this. I want the setting. The setting tu. Jangan tukar. Takut ada orang tukar. Setting tak sama.
So that means we just screenshot the setting first and then
the setting is one screenshot. This one.
Yes.
Tengok SI ke PU kan. Tadi kita SI, PU, this one. And then
the table.
Yang table. You need to do the table here. This
table
one.
In result lah kan.
This one. Okay, this one is contohnya kalau sini tadi yang sini constant. Okay, ni pula sini constant. Okay. And then for the second one, you letak the first one constant. Okay, so just change sini saja. So you see, so results ini adalah didarab lah. Sini darab kan? Darab lah. Berapa? Okay, B1 darab. Ataupun kita boleh itulah. B1 darab I1. Okay, sini B2 darab I2 kan? Okay. So, kalau kamu boleh buat graf lah. Buat graf.
Okay.
Apa nama? Dia punya tu resistance tu dengan power versus power.
Okay, so
as the resistance to increasing, power tu sepatutnya decreasing kan? Okay, that one you can use Excel. Lagi senang kan? You can do this table in Excel. Nampak berapa lagi senang nak buat graf kan?
Sir, saya ingat saya cakap tukar winding resistance yang both winding at the same time. You have satu constant.
It's like I said, it's up to you. You can do it in one, or you can do it in two. Okay, into
Okay.
it's up to you. Okay, because kalau kita nak tengok, if you change just the first one, P2 is affected or not. Okay, like this one, if you just change the second one, P1 is affected or not. Okay, you cannot see that if you change both of them at the same time, kan? You don't know whether these changes due to the changes here or the changes here. So that's why you can do it in two. Ini constant, ini tukar. Atas bawah sini yang constant, sini tukar. Right? So that you can actually see the effect of changing the winding resistance tadi. Okay? That is one task. Ya, task lagi satu tadi yang itulah kita cari apa winding kan. Berapa? N1 over N2 lah. Kan?
Okay.
Okay, N1 over N2. Because this is the only ratio that you can get right now. Okay, ratio saja. Because, ya, we don't know berapa banyak winding the first one. Okay. Or kalau ada orang rajin nak kira kan berapa berapa banyak winding dalam ni kalau nak kira. Bagi saya tak payahlah. No need to calculate lah. Just dia punya ni saja. Just tunjuk berapa dia punya ini voltage dia. Okay, as for the second one tu, the second experiment, the results dia sini adalah you need to show ini graph scope tu tunjuk this one scope. The scope for this kena tunjuk. Ini pun scope dia kena tunjuk. This one. Okay, scope dia kena tunjuk. And then you need to also show berapa dia punya sebab kita tukar voltage sahaja. So how much is the current? I1 berapa? I1 berapa? Salah. I2 berapa? Okay, because you are changing the voltage, the voltage kan? Okay, so ini V2 secondary voltage. This is the secondary voltage is V2 equal to apa? V2 equal to 240 volt lah. Because kita stick with the one in Malaysia lah. Okay? 250 volt, 50 Hz. Okay? This one. Of course, with the inilah, with dia punya scope. Okay? Ini je eksperimen number 3. Eksperimen 3. Lab 3. Ya kah? Lab 3 kah? Eksperimen 3 kah? But yeah. Lebih kurang lah. Yeah, so this is up to you. Which one? 3.1, ini 3.2 kah? Ini kah 3.1, ini 3.2 kah? Up to you.
So not,
Okay? Yeah.
not current I1, I2 ya yang kita tanggarah display RMS current ke?
No, RMS, okay, so, okay, let me show you here. This RMS here, this display is current display. Okay, dia bukan tunjuk, it's not showing the actual value of current. Okay, so the actual value of current is here. You buka sini. You need to zoom here. Tentunya. Okay, ini current lah, betul lah. Okay, you need to zoom here. Tengok ni dalam berapa sini. Tengok zoom lagi berapa peak ni. Ambil peak sini. Okay, 1.4 berapa ni. You estimate here. Okay, and then bahagi dengan square root 2 untuk dapatkan dia punya RMS. Oh, dah makin nampak dah tu. Makin sini ya. Okay, sini lebih kurang. Ini value ni. This is the actual value tadi, the peak value is here. Okay, the one that is shown here is just ongoing, current, ongoing value. Because ini tengok 294, sejak bila kamu letak ni kan? Voltage 294, tak ada kan? Mana ada? Kita tak letak pun voltage 294, but it baca 294 from where? But because ini dia follow here tadi, primary voltage dekat sini, yang tadi tu. Okay, dia ikut currently berapa? It's just the running number, this one, the running value. It's not actual value. So actual value, you need to look at the scope. Ya Allah, salah tekan lagi. Okay, you need to actually look at the scopes. And, alamak, dah hilang lah. Ke saya kata letak ini. Okay, so you need to actually look at the scope and do reading here. Tengok berapa. Faham tak? Boleh tak?
Sir,
Ya?
boleh ulang lagi tak?
Okay, so for yang V, kita nak kira power tadi kan. You want to measure power tadi, you nak kira P darab V kan? I darab V kan? Okay, voltage you know already berapa? Okay, sebab kita letak dah voltage ni. Sorry. Okay, sini tadi 400. Contohnya lah, kalau you letak 400 berapa kan? Current is, you need to measure. Okay, you need to measure the amount of current by looking at the scopes. Okay, the one that is shown here in this display is not the RMS value. Ini cuma tunjuk current value, bukan current yang arus tu. Current maksud semasa. Okay, that's why during the experiments you see that dia punya tu berubah-ubah. Okay. Again, I need to malas tu lah saya tarik ni lagi sekali. Kena tukar sekali lagi lah. Okay, so it's not the actual value. Okay, you need to remember that. Okay, that one is just current value saja. So that's why if you run this experiment, tengok if you run, salah, 0.1. Okay, run experiment, see the value of your display here, dia bertukar-tukar. Okay, see, it fluctuated from, okay, because dia follow everything. Ini apa hal saya punya jadi saya dah tukar kah? Saya ada kacau tadi kah? The setting, saya lupa. Okay, so the way for you to get the value of current is again by going into the and look at this value. Berapa? Mana you estimate berapa paling tinggi? Ini paling tinggi. Ini lebih kurang 1.45 lah. 1.453. 31. Estimate sini berapa? No, ada. 45314 current dia. Ini dah detail sangat kan? Kecil sangat. Okay? So that is the value that you should use in your calculation of power tadi. This one. P equal to IV sini. Sini I. Okay? Faham tak? Ke tak faham?
Faham, sir. Thank
And then
you.
you must remember that one is the apa nama? That one is the what you call that? Peak value. You still need to find the RMS value. Okay? RMS value means you divide by square root 2. Okay? Faham ke tak faham ni? Okay, although you can also use MATLAB. There is a function in MATLAB. Here pakai sini kita boleh, you can actually kira berapa this one. Tools. measurement. Peak finder. Ah. Okay. Here is the peak finder. Ada 2 biji. So use this value here. Tools, measurement, sini. You can actually drag this. So tengok sini. Dia akan tengok tepi sini. Primary current peak settings dia berapa? Dia akan bagi. Okay, kalau so explore lah. Okay, explore this to find the peak tu, and then you can find the RMS value to calculate the power. Boleh? Ke tak boleh? Boleh kan? Any more question? Hello? Ke semua tidur lah? Puasa? Oh. Hello?
No questions, sir.
Yeah?
No question.
Okay, good.
No.
Okay, for now tak ada question. It's okay. Tak apa. Boleh, you can shoot any... Yeah, you can shoot any question. You can use the tools here. Zoom Y, zoom out, pan, access scaling, save. Okay. Measurement here, signal statistic. Okay, signal statistic. Ada. Sini apa? Lagi senang sini kan. Max value is around this. Yeah, 1.453. See? Tak payah kira pun. Dia bagi dah sini ya. Okay. Then yeah, you can use this. This one is remember this one is peak, peak. You need to use the RMS. Okay, so there will be no labs tomorrow, but you can always ask me any question you want. If you need help with this. Okay, so I think I've shown you here. Okay, you can do this kind of measurement. Okay, and it's actually very easy already right now. Okay, everything is given. Okay, it's just the matter of pergi explore. Okay, if you explore this, then you will see there's a lot of useful functions. Okay, useful functions that is provided by MATLAB here. Okay, so that's it. Okay, so keep exploring. Okay, so
just want to reconfirm.
Apa dia?
Just want to reconfirm. Currentnya tadi untuk cari power lah kan. So
yes.
So yang the first experiment, I mean the 3.2 yang kita ubah voltage winding ya. Our task is just to find the ratio of
windings, yes.
Okay.
Ratio of the windings too, and then you can just show the voltage lah, show the apa nama ini juga lah. You still need to show this.
The scope.
Yes.
Alright.
Bukan eksperimen tak ada scope, then buat apa kita buat eksperimen kan?
Okay, sir. Okay? Thank you.
Yeah. Anything else? If not, then yeah, I think this is it for today. Yeah. Somebody is calling. Who? Yeah. I will do it today. Yes. Okay. Ingat saya ada kelas saya sebelum ni sampai dah 1 semester saya lupa dah letak dia punya video online. Kalau leceh ada upload YouTube lah semua kan. Dia tak boleh upload directly on Elim. Okay. So saya ni bukan content creator kan. So nak upload ke YouTube tu atau ni atau itu leceh. Tapi yeah, I will try by today. Okay. So that's it, yeah, for me today. So I will leave it to you for the experiment. So looking forward for the reports this Friday, and then the report is submitted through groups. So only one group member is required to do the submission. And then for next week, every single group, saya nak semua group present. Okay. Semua group present. Saya tak nak ada group yang tumpang sekaki saja. Okay, I want everybody to actually, do this. Okay, do the experiments. Okay, so that's it for me today. All the best.
So
And
attendance.
stay safe. Yeah.
Excuse me, sir. Attendance, please. Attendance.
Okay. You want to ask something?
Dah. Sikit last.
Ya. Apa dia?
Dekat transformer yang voltage peak ke RMS value? Lupa ambil.
Transformer tu adalah peak.
Okay.
Okay, because as you can see, kalau tengok tadi kita set berapa? Voltage tadi primary voltage 200 kan?
400.
400 kan? Tengok 400, and then as you can look at, as you can see, 400.
Okay.
Yeah, it will give you peak voltage, not RMS. But for calculation of power, you need the RMS lah.
Alright.
Okay.
Thank you, sir.
Yeah, problem. Anything else?
So attendance, sir.
Tada? Oh, attendance siapa ni? 65808 kah? Siapa tu? Siapa tadi nak attendance tadi?
Dik Hu.
Who?
Dik Hu.
Dik Hu. Oh, okay.
Saya, sir.
Ya, siapa? Ya, bagi saya kira. Siapa ni?
Terry anak Vincent.
Terry. Okay, Terry. Mana gambar kamu, Terry?
Tak tahu kenapa tak ada, sir.
Yeah. What happened? There is no video. Your primary tak ada gambar.
Tak tahu, sir.
Yeah.
I think masa register tak ada gambar, sir. Lupa nak
saja kamu pun tak bagi kan?
Abdullah, sir.
Yeah, Abdullah, you're here today, Abdullah.
Yes, sir.
Hey, you already how many courses left for you?
I'm same with them. Third year.
Same. Oh, okay. So you are PKEE, right? Semua orang
Yes,
PKE, tak ada orang stay with PKEK, PKET, tak ada kan?
Tak ada lagi.
No more. Okay. So what about the others? Doriel, Naim?
Saya Liu.
Airan? Oh, Liu ada.
Yeah.
Okay.
Okay, thank you, sir.
Yeah, no problem. Hazira,
Number 3,
mana?
sir.
Hazira. Yeah, who?
Awangku.
Mana awangku? Awangku 65513. Okay.
Okay, thank you, sir.
No problem.
Hello, sir.
Okay, yeah. Saya dah letak tadi, set attendance. Okay. What happened? Oh, okay. So, refresh lah.
Nombor 1, sir. Doriel.
Oh, ada Doriel. Where were you?
Saya pergi tandas.
So yeah, for Sarawakian, tak kisahlah Sarawakian ke non Sarawakian ke, stay safe and then stay clear of crowded places, especially now baca banyak ni apa nama tu yang pasal Ramadan semua, people a lot of people going to the same places, okay, with very little social distancing and all that, can lead to increased number of cases, daily cases. So yeah, please be careful out there. And then I know the semangat puasa tu, semangat Ramadan tu. Kalau rasa kalau tak pergi apa nama pasal Ramadan rasa tak dekat rasa kan bulan puasa. I know that the urge is there, but itulah. Just be careful.